Good evening, everyone. Can everyone hear me?
Yes, sir. Good evening, sir.
Yes. Samragni or Viksha, can you people hear me?
Yes, sir.
Yes, sir.
Okay, so everyone, we can start. Okay, last day we were doing binomial theorem. Let us continue. So can you people see my screen? Hello, can everyone see my screen? Okay. So first of all, let us discuss the homework questions. Many people have not sent their homework. Let's see.
Sir, I've done it. I will send it after the.
After the class. But you were supposed to send before the class, isn't it?
Yes,
Avigyan, what happened?
yes.
And those who were not attending the class till now, like Abhipsha and Samragni, did you people go through the recordings? Tell me.
Sir, I went go through the binomial recording.
Okay. And Abhipsha?
Yes, sir.
Okay. What about others? Or if did you send me your homework?
No, sir, my exams are going on. So I'll send you by tomorrow.
But there are other people also. They are having their exams, but still they are sending their homework. Right? Tell me.
So I'll send by tomorrow.
I have sent only 10 problems. You cannot do 10 problems also at home. Tell me. Okay. Don't give an excuse. Try to understand. You're not preparing for boards only. Okay, next. Let's see. I think Shivankit, you also have not sent me your homework. Shivankit,
Yes, sir.
what happened? Tell me.
I was doing a little bit was left.
You were doing what?
I was doing it, but a little bit of that was left.
You should have sent it. Whatever you could do, you should have sent it.
I thought I would
Next.
come first and then.
No, no. Like whatever you could do, you send it. Okay. The rest of the problems you ask me in the class, no problem. Next. Okay. Raunak, you were supposed to send me the Sunday's homework also. Did you
Yes, I
send?
sent. I forgot. I sent today.
Send it.
I
Okay.
sent.
And so, anyways, let us discuss the homework questions. Okay, number one. Number one, there are three answers. Okay, n equal to 2, 3, 4. Anyone having any doubt in number one? Let me know.
Yes, sir.
N equal to 2, 3, 4. If there's anyone having any doubt, you can ask me now. N equal to 2, 3, 4. Okay. Number two, the answer is 3 to the power 50 plus 1 by 2. Okay, that is option B, I guess. Yes. Number three, R equal to N by 2. Anyone having any doubt? One, two, three, tell me. One, two, three. Anyone having any doubt? Next, number four, option D. Number four is option D.
So I can please do it. Number 4.
Number 4. Okay, let us start. In number 4, it is written, if the fourth term in the binomial expansion is equal to 200 and x is greater than 1, you need to find out the value of x. So let us start. Okay. Fourth term in the binomial expansion. Okay. Fourth term in the binomial expansion. Over here, first of all, at first, what I'm going to do is, I'm going to take x to the power 1 by 12 common out. Okay. So what are we getting? We'll get x to the power 1 by 12. Or, wait a minute, they are asking us fourth term. That means t3 plus 1. Right. Tell me, Shwankit.
Yes, sir.
Okay. R equal to 3. What is happening? Okay. T3 plus 1 will be equal to 63 into square root of x to the power 1 upon 1 plus log x. 1 upon 1 plus log x whole cubed into x to the power 1 by 12 whole cube. Tell me. This is given as 200. Tell me. Okay, next. What is the value of 63? 63 is 20. This will go by 10. Okay, next. So x to the power 1 by 1 plus log x. Let us simplify this. Okay, this will become x to the power. Okay, removing the square root. X to the power 1 by 1 plus log x whole to the power 3 by 2. Okay, multiplied by x to the power 1 by 4. This is equal to 10. Okay, so when bases are same, powers are added. Okay, or what we can do is, do you remember how to simplify this kind of equation? X to the power log of something. I mean, there is a log over the power. We used to take log to the base 10 on both sides. Right, do you remember? So let us take log to the base 10 on both sides. Okay, on taking log to the base 10 on both sides, okay, we are going to get, uh, okay, we are going to get, first of all, let us add the powers, x to the power 3 by 2 into 1 by 1 plus log x plus 1 by 4 is equal to 10. Okay, now taking log to the base 10 on both sides. So we are going to get 3 by 2 into 1 by 1 plus log x plus 1 by 4 multiplied by log x 1 by 1 plus log x. Okay, into log x, this is equal to 1. Yes. So what I'm going to do is, over here I'm going to take log x as some k. So let log x equal to k. Okay, let us see what kind of equation it is. So we'll get 3 by 2 into 1 by 1 plus k plus 1 by 4. Let us multiply it. K by 1 plus k plus k by 4. This is equal to 1. Let us simplify. This implies 3 by 2 wait a minute. Taking 3 by 2 to the right hand side. Over here taking 4 as LCM. 4 into 1 plus k as LCM. Numerator would be 4k plus k square is equal to 2 by 3. Okay. Next, I think we have to cross multiply. So we get 3k square plus 3 5s are 15k is equal to 2 4s are 8 plus 8k. Okay. So on simplification, we are going to get 3k square plus 15k minus 8k is minus plus 7k minus 8 equal to 0. This is what I'm getting. Okay. Is it factorizable? Have I done a mistake or what? Let's see. K by 1 plus k by 4 4 into 1 plus k, 4k plus k square plus k. Okay, 4k square, 4k plus k square plus k. Wait a minute. The power will come in front.
Sir, I think this is 3 by 2 into 1 plus log x plus 1 by 4 separately. I think you
Wait,
have
wait,
taken.
wait, wait, wait. Oh, acha, yes. 1 by 4 was separately. You see
Yes, sir.
over here, 1 by 4 was separated. Okay, over here I have done a mistake while addition. Okay, plus 1 by 4. Okay, plus 1 by 4 like this. Wait a minute. Over here I have done a mistake. Okay, acha, now let us solve. Taking log on both sides, we'll get 3 by 2 into 1 by 1 plus k. Okay, plus 1 by 4, that is k by 4 is equal to 1. Okay, now let us take LCM. LCM would be 4 into 1 plus k. 4 into k plus 1. Numerator would be 6 plus k square plus k is equal to 1. Okay, so this implies we'll get k square plus k plus 6 is equal to 4k plus 4. I think now we should get it. So we'll get k square. K minus 4k is minus 3k plus 2 equal to 0. Okay. So this implies we'll get k equal to 1 comma 2. Okay. So will both the values satisfy? K equal to 1 comma 2. I think it will satisfy. Acha, k is great. So see over here it
Well,
is written.
I have a question. Like
Wait,
when
wait,
we
wait,
get
wait. Wait, wait. Just give me 1 minute. Give me 1 minute. K equal to 1 comma. I'm getting. Yes, tell me. What question you have?
when we multiplied k over the entire thing, it should be 3 by 2. Then k plus k divided by 1 plus k plus 3 by 4. Shouldn't it be like everything is coming outside? Then we have log x. Then
Wait, wait, wait.
why
1
are
by
we?
4 like this, right?
Yes. We
Acha, yes,
multiplied.
yes. Wait. 4 into k plus 1. Numerator would be 6 plus k square. No, it will not be k square anymore. Wait a minute. From here I'm simplifying. 4 into k plus 1. So this will be 6 plus k plus 1. Okay. This
Sir,
whole thing is multiplied by k.
yes.
Wait a minute. Wait. So from here, what are we getting? We are going to get k plus 7 into k, that is k square plus 7k equals to 4k plus 1. 4k plus 4. This implies k square plus 3k minus 4 equal to 0. Okay. So from here, we are going to get k equal to, I think 4k minus k. Yes, k equal to 4 and, sorry, plus 4k minus k. So k equal to minus 4 comma 1. Okay. So but see, log cannot be equal to negative. So, acha, wait. Log can be negative. So log x is equal to minus 4 and log x equal to 1. This implies x equal to 10th power minus 4 or x equal to 10. Okay. So hence the answer is option D. Tell me, is it clear to Ankit?
Yes, sir, clear.
Okay. Okay, next. Let us move on to another one. Question number 4 is 10. Number 5, we need to find out the value of n. Over here, the answer is given as, over here, the answer is given as, let Let me see. Plus x square whole square. A1, A2, and A3 are in AP.
This
What
is the
was the
same.
answer? Oh, this is the same question. 1 and 5, I repeated it by mistake.
Sir,
Okay. Yes, Shamli, tell me.
sir, can you please solve this one?
Number 5 and 1. Actually, over here, 1 and 5, I repeated by mistake. Wait. I'm solving this one. Pay attention. So over here, 1 plus x square whole square into 1 plus x whole to the power n is equal to summation of k equal to 0 to n plus 4 ak into x to the power k. A1, A2, and A3 are in AP. We need to find out n. Okay. So basically, over here, you are going to get, Shamli, this summation will be equal to A0 x to the power 0 plus A1 x to the power 1 plus A2 x square plus A3 x cube plus dot 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 dot. Okay. So what can we say? We can say that A1, A2, A3 are in AP. That means the coefficient of x, x square, and x cube are in AP. Tell me.
Yes, sir.
Okay. Now let us find out the coefficient of x. What is the coefficient of x over here? Tell me. Coefficient of x will be equal
A1.
to A1. On the left hand side, what do we get? NC1. We are going to get coefficient of x to the power 1 only over here. Are you getting? This is the 1 plus x square whole square. You won't get anything over here. Okay. They are only even powers. Basically, when you simplify this 1 plus x square whole square into 1 plus x whole to the power n, you are going to get 1 plus 2x square plus x to the power 4 into 1 plus x whole to the power n. This will be equal to 1 plus x whole to the power n plus 2x square into 1 plus x whole to the power n plus x to the power 4 into 1 plus x whole to the power n. Right, Shamli, are you getting? So A1 will only come from here. That is x. Over here, you won't get any x. Next. Where will you get x square? Over here and over here? Right, tell me. So what is x square? I mean, coefficient of x square. A2 will be equal to, from here, what is the coefficient of x square? Tell me. Shamli. Over here, what is the coefficient of x square? What happened? It's very simple. Over here, what is the coefficient of x square? It's a simple binomial expansion.
Sir, it's 1.
1. You were present last day, right?
Yes, sir.
So, anyone tell me what is the coefficient of x square over here?
NC2.
NC2. Formally go through last class again. Okay. And over here we'll get the coefficient of x square only with the first term. 2x square into NC1. So it will be NC2 plus 2. So formally, are you getting? Or should I explain?
No, sir, I got.
Got it. So if you have got it, tell me where will you get A3? Over here, what is the coefficient of x cube? Tell me.
NC3.
NC3. And over here, you will get the coefficient of x cube when x square is multiplied to x.
Yes, sir.
So tell me.
Sir, won't sir A2 will be NC2 plus 2 NC1, right?
NC2 plus 2 NC1.
Because in 1 plus x to the power n, the NC1 term will also come when multiplied by 2x square. The coefficient of x square will become 2 NC1.
Okay. Sorry, let me explain. try to understand. Over here, we need the coefficient of x square, right? When x square is multiplied to 1, then only you'll get x square, right? Tell me,
Yes, sir.
what is the coefficient of 1? I mean, tell me, what is the coefficient of 1? Where will you get 1? Over here, in this expansion, tell me. Is it NC1
Uh,
or NC0?
oh, yes, sir. Yes, sir. So,
Is it clear?
I understood. Yes, sir. Yes, sir.
Okay. Coming back to Shomali, tell me, NC3 plus, over here, tell me, what is the, I mean, when x square is multiplied to x, then only you are going to get x cube. Yes or no?
Yes, sir.
So tell me, what is the coefficient of x over here?
NC1.
NC1, correct. So plus 2 into NC1. Is it clear? Now see, A1, A2, and A3 are in AP. Okay. So this implies 2A2 is equal to A1 plus A3. Okay. This implies 2 into NC2 is equal to A1, that is NC1, plus A3. 2 into NC2 plus 2, sorry. 2 into NC2 plus 2 is equal to NC1 uh, plus NC3 plus 2 into NC1. Okay. So let us start. Okay. So 2 into NC1 and over here NC1. This will become 3 NC1. Okay, let us simplify. So 2 into NC2 plus 2. So n into n minus 1 by 2 plus 2 is equal to NC1 is n plus n into n minus 1 into n minus 2 by 6 plus 2n. Okay, let us simplify. When you multiply, when you open the brackets, you are going to get n into n minus 1 plus 2 2s are 4 is equal to 6 as LCM. 6 is 18n plus n into n minus 1 into n minus 2 divided by 6. Okay, we'll get a cubic over here. So 6 into cross multiply, we'll get 6n square minus 6 plus 24. 6n plus 24 is equal to 18n plus n cube minus n cube minus 3n square plus 2n. Okay, when you simplify, you are going to get n cube minus 3n square minus 6n square minus 9n square plus 20 plus 18n plus 6n, 24n plus 2n, 26n minus 24 equal to 0. Okay, you will see that n equal to 2 is a factor. Are you getting? N equal to 2 is a factor. Okay, and when you factorize, you are going to get n minus 2 into n minus 3 into n minus 4 is equal to 0. This implies n equal to 2 comma 3 comma 4. Then is it clear, Shomali?
Yes, sir.
Okay. Okay, so 5 I repeated it with number 1. Okay, so you should have done only 1. Okay, if in the expression of 1 plus 5 whole to the power n fixed 6 and 7 terms are in AP, similar type of problem, everyone. Okay, over here the answer is n equal to 7 comma 14. Okay, anyone having any doubt, you can ask me. N equal to 7 comma 14. Next, number 7. Number 7 is a proof problem. Anyone having any doubt, tell. Number 7.
Was my method completely wrong because I was getting 2n plus 1 cn.
Okay, 2n plus 1 cn. Let me solve. Okay, this is number 7.
So was
Very
my
good.
method correct for this question?
Method was correct. Okay, I think in between you are making some calculation mistake.
Yes.
Okay, let me solve step by step. Summation of AR into x minus 2 whole to the power r is equal to summation of r equal to 0 to 2n br into x minus 3 whole to the power r. Oh, they are same. And ak equal to 1 for k is greater than or equal to n. Should it bn equal to 2n plus 1, cn plus 1? Okay, let us start. So I think first of all we should expand. Okay, this is number 8. 8, right? No,
Yeah.
7. Okay, let us expand. So we are getting a0 into x minus 2 whole to the power 0 plus a1 x minus 2 plus a2 x minus 2 whole square plus dot 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 plus an x minus 2 whole to the power n. Okay, plus an plus 1 x minus 2 whole to the power n plus 1 plus dot 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 up to 2n. A2n x minus 2 whole to the power 2n. Okay, this is equal to b0 x minus 3 whole to the power 0 plus b1 x minus 3 whole to the power 1 plus dot 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 plus bn x minus 3 whole to the power n plus bn plus 1 x minus 3 whole to the power n plus 1 plus dot 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 plus b2n x minus 3 whole to the power 2n. Okay, are you people getting? Tell me, I have totally expanded it.
Sir, I understood what mistake I made.
Okay, so should I complete or you can do it?
No, sir, I can do it.
Okay,
I just understand. Like I had considered it y and y plus one, and I forgot to simplify the coefficients of y plus one and
okay,
nine.
okay. Still, anyone needs the solution, let me know. I'll solve it completely. I've just expanded it. Is there anyone who still needs the solution? Tell me. Okay, next. Then I'm moving on to question number 8. The answer is option B. Okay. Hello, Rasheshwari, Anvesha, you people didn't send me your homework. Hello, Rasheshwari, can you hear me?
Yes, I didn't join the last class, sir. That's why I couldn't send the homework.
Did you go through the recording?
Yes, I saw the recording. I will do it.
And Anvesha, did you send me your homework?
No, sir. I could do only four, so I didn't send it.
Should have sent it, even if you have done 4.
Okay, sir.
Did you attend last class?
No, I did not. I did the see the recording.
Okay. Question number 10, the answer is option D. Anyone having any doubt? Up to 10, tell me.
Sir, could you please discuss question number 8? That's all.
8. This one?
Yes, sir.
Okay.
I
Alpha
could
square plus.
do like a sum part, first few steps, then I got stuck.
Okay, let me solve. Let's see. So this is question number 8. Alpha greater than 0, beta greater than 0, maximum alpha cube plus beta square is given as 4. Okay. And over here, the term independent of x. Okay. So they are asking us the term independent of x. Okay, let us see which term is independent of x. So what is TR plus 1? TR plus 1 is equal to,
TR plus 1 10 CR into alpha x to the power 1 by 9 whole to the power 10 minus r into beta x to the power minus 1 by 6 whole to the power r.
correct. Okay. So let us see the coefficient of x. If the term is independent of x, for term independent of x. N minus r by 9 minus r by 6 should be equal to 0. Right? Tell me.
Yes, sir. R is
Nice.
4.
Okay, r is coming as 4. We got it. So if r is 4, what is t4 plus 1?
10c4 alpha to the power 6 beta to the power 4.
Correct? Correct, correct. Okay. So next. I now over here it is given the maximum value of the term independent of x is 10k. I need to find out the maximum value of this expression. Just to see, alpha cube plus beta square is given to us. We need to find out the maximum value of alpha to the power 6 beta to the power 4. What shall we use? Tell me. Sum is given. We need to find out the maximum of the product. What shall we use? Tell me.
AMGM.
AMGM. Very good. Right. Tell me. Okay. So when you're using AMGM, okay, see to it that you are getting alpha to the power 6, beta to the power 4 on the right hand side. Are you getting? So, okay, anyways, let's see alpha cube plus beta square divided by 2 must be greater than or equal to square root of alpha cube plus beta square. Alpha cube beta square. Okay. So what is the alpha cube plus beta square is given as 4. So alpha cube
Yeah,
beta square.
alpha square plus beta square is given as 4. So can't we write it like alpha square by 2 plus alpha square by 2, and in that way we can make the product, because alpha square plus beta square is given as 4.
I understood. I understood. You want to break it, right? Alpha cube by
Yes, yes.
2 plus beta square by 2.
Yes,
Okay.
yes.
Yes, you can do it, no problem. But instead of that, what I'm going to do is I'll find out alpha cube beta square maximum. Okay. And then I'm going to square it. Okay. Because the square of alpha cube beta square is alpha to the power 6 beta to the power 4. Are you
Okay, sir.
getting? Ritom.
Okay, sir. Okay, sir.
And this is less than or equal to 4 by 2, which is 2. Okay.
So
Squaring both sides.
how are we going to use the fact that they have given alpha square plus beta square is equal to 4?
No, no. They have given alpha cube plus beta square.
Oh,
See,
sorry,
they
sir.
have not. No, no problem. Ritam, you also have not sent me your homework, right?
Yes, sir.
Send it to me by tomorrow. Okay.
I have consecutive exams. I will send it after tomorrow's exam.
See, everyone has exams.
Okay, sir.
Okay. You are not only preparing for boards, remember.
Okay, sir.
So T5 max. T5 max will be equal to 10C4 into 2 square. Okay. Actually, 2 twos are 4. It should be 4 over here. Sorry. Wait a minute. It should be 2 only. When you square both sides, you are getting 4. So 4 square. 10C4 is how much? 10 into 9 into 8 into 7 divided by 24 into 16. 4 times 6, 4 times 4. Okay, 6 times this will go 12. 12 and the 84 into 10, 840. Acha, this is nothing but this is given as 10k. Right, I need to find out the value of k. So 10, 10 gets cancelled. We are getting k equal to 84 into 4. That is 336. Is it clear, Shamini? Tell me.
Yes, sir.
Okay.
Sir, in this step, like t of 4 plus 1, uh, alpha cube plus beta square by 2 is greater than equal to square root of alpha cube plus beta square.
Square root of
So,
alpha
sir,
cube beta
this,
square.
sorry, yes, sir, I mean square root of alpha cube beta square. So, like, sir, how the sign is changing? Oh,
Sign.
no, 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 sorry, sir, I understood. Like, it was opposite, so I got confused a little bit. I understood,
I,
I understood.
I just took it to the left hand side. Okay. Anyways, anyone else having any doubt? 9, 10? Tell me. See, the 10 came in J means this year only. See, the question is easy. Must have done it. Anyways, let us continue, everyone. Last day we were discussing binomial coefficients, and I have discussed van der Waals identity. Okay, let us discuss some more problems, everyone. Okay, on the sum of binomial coefficients. Okay, so question number one for today. Show that show that C0 C1 plus C1 C2 plus C2 C3 plus dot plus Cn minus 1 Cn is equal to 2n Cn plus 1. Solve. Once you have done it, send me the full proof. Okay, whole proof. Those who didn't attend last class, you people understood the homework solutions, right?
Yes, sir.
Okay. Samragni, you understood? Samragni, Oiksha, you people understood? And Samragni, did you go through the recording?
Yes, sir, I did.
Okay.
Sir, can you explain me question number 5 once?
Homework question?
Yes, sir.
Oh, why didn't you say before? Tell me.
Sorry, sir.
Acha, first of all, you solve this problem. After this problem, I'll discuss.
Okay, sir.
Okay, should I start, everyone? Question number one.
Yes, sir. You'll take it.
Okay. Send me the complete solutions, everyone. Yes. Ritam, your answer is correct. Okay, so everyone pay attention. I know three methods of proving this one. Okay, tell me which one should I use? Okay, one is by comparing coefficient, another by using combinatorics. Two methods. There is supposed to be one more. Using Vandermont's identity. Which one should I use? Tell me.
So you can use combinator x in one van der Waals identity and send in the comparing coefficients.
Okay, using okay, using combinatorics. Okay, everyone. Method one, using combinatorics. Okay. Next. Okay, C0, C1. Can I write it as, first of all, see, your task is to make their sum equal. Okay. In order to use combinatorics, try to make their sum equal. Okay, like 0 plus 1 is 1 over here, 1 plus 2 is 3 over here. Try to convert it so that they become equal. Like for example, you see C0, C1. Can I write it as C0 into, oh, no, no, not C0. C1 into Cn. Tell me. Sorry. Cn into C1. Tell me. Can I write this? Tell me, everyone. Instead of C0, can I write Cn? Yes or no? Tell me, everyone. Tell me. Pratyay, Rasheshwari, Anvesha, Abhiksha, Madhurjo, tell me. Are you people getting? Instead of C0, I have converted into Cn.
Sir, why?
You will understand after some time.
Okay, sir.
Plus C1, can I write it as Cn minus 1 into C2? Tell me, Aisha.
Yes, sir.
Plus C2, I can write it as Cn minus 3 into C3. Wait a minute, Cn minus 2 into C3 plus dot 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 dot. Last one, Cn minus 1, I can write it as Cn plus 1 into Cn. Wait a minute. No, Cn minus 1, C1 into Cn. Yes. Okay. Now, why I have done this? If you recall, if you recall our last class, why did I do it like this? You people will understand. If you recall our last class, the way I have proved this one, can you people recall? C0 square plus C1 square plus C2 square plus Cn square. Over here also, while proving with combinatorics, I converted. I mean, you see, C0 into Cn, this Cn got converted into C0, then we got C0 square. Are you getting? One of them I converted and I got C1 square. One of them I converted and I got C2 square. Tell me, are you getting, Oibsha?
Yes, sir.
From where I got the idea of converting? Okay.
Sir.
Now, now you see that their sum is equal, right? Now what you do is you consider 2n students in a class. Consider 2n students in a class. Okay, in which there are n boys and n girls. Okay. So Isha, tell me what is the number of ways to select n plus 1 students? Tell me, Isha, what is the number of ways to select n plus 1 students? 2nc n plus 1? Right, tell me, Isha. That is our right hand side. Okay, now breaking the cases. Okay, to prove the left hand side, I'm breaking the cases. Okay, so type of selection and ways to select. Tell me, Samragni, Shinika, people getting? Madhurjo, are
Yes.
you getting this?
Sir, I had sent the answer.
Yes, I'm checking. I'm checking. Adrija, are you getting? Tell me.
Yes,
Okay.
sir.
Adrito, are you getting?
Yes, sir.
Okay, type of selection. So it can happen that you have selected one boy and n girls. Right? Tell me, Aisha. Yes or no? This is one way of selection. One boy and n girl.
Yes, sir.
Avisha, this can be done in NC1 into NCN. Yes or no? Tell me. Are you getting?
Sir, how?
Number of ways to select one boy out of n boys is NC1.
Yes, sir.
Number of ways to select all n girls out of n girls is NCN.
Yes, sir. Yes, sir.
Is it clear? Similarly, you tell me another way of selection is two boys plus n minus one girl. Right. This can be done in NC2 into NCn minus 1. Right, tell me, Aisha. Yes or no?
Yes, sir.
Another way to select is three boys and n minus 2 girls. That can be done in NC3
NC3 N
into
C N minus 2.
n minus 2. Dot, 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 dot. Right, Aisha.
Yes, sir.
So see, what are we getting? We are going to get C1 into Cn plus C2 into Cn minus 1 plus C3 into Cn minus 2 plus dot, 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 dot plus Cn into Cn minus 1 into C1. Okay. So again, let's see. These two expressions are same only, right? After conversion. Okay. After this, you can also convert it. You can write it as C1 into Cn minus 1, C1 into C0, and C0 into C1, plus C1 into C2, plus C2 into C3, plus dot, plus Cn minus 1 into Cn. Is it clear, Alpha?
Yes, sir.
Okay, I think this should be Cn minus 1. I think this should be C1 into Cn. Huh. Okay, because n boys and 1 girl. Okay, hence proof. Hence proof. Okay, using combinatorics. Okay, but there are other ways also to prove it using Vandermont's identity. And yes, yes, Adrija, your answer is correct. Tell me, Protter, did you understand?
Yes, sir.
Jatra, is it clear?
Yes, sir.
Okay. Acha, Adri, okay, Ahir, wait a minute. Ahir, after that, you have to convert it into 2nc n plus 1. Okay, are you getting? Okay,
Yes, sir.
so everyone, should I do other methods also, or you people have understood using combinatorics? Wait, let me do it by using binomial expansion. Okay, so everyone, what is x plus 1 whole to the power n? X plus 1 whole to the power n is equal to C0 x to the power n plus C1 x to the power n minus 1 plus C2 x to the power n minus 2 plus dot plus Cn x to the power n minus, okay, Cn. And what is 1 plus x whole to the power n? 1 plus x whole to the power n is equal to C0 plus C1x plus C2x square plus C3x cube plus dot plus Cn. And when you multiply, what are we getting? We are going to get x plus 1 whole to the power 2n. This is equal to C0 x to the power n into this whole thing. Okay,
Sir, that will be Cn x cube 1.
which one? Oh, last one. Yes, you're correct. Plus C1 x to the power n minus 1 into the whole thing. Okay, tell me, are you people getting? So, Ankit, are you getting? Tell me.
Yes, sir.
Okay, plus C2 x to the power n minus 2 into the whole thing. Okay, like this, it keeps on going. Okay, plus Cn x to the power n, the whole thing. Okay, next. So, everyone, on the left hand side, on the left hand side, what is the coefficient of? Achha, wait, let me see. C0 into, what is C0 into Cn? X to the power n.
In the last term, it will be Cn only, not x to the power n.
Which one? Which one? This one? Yes, yes.
Yes, sir.
Only Cn. Only Cn. Let me see. Uh, with C1, with C0 into C1, you are getting x to the power n plus 1. C1 into C2, x to the power n plus 1. C2 into C3, x to the power n plus 1. Are you people getting? So, what is the coefficient of x to the power n plus 1 on LHS? Tell me, everyone. What is the coefficient of x to the power n plus 1 on the LHS? 2nc n plus 1. And what is the coefficient of x to the power on n plus 1 on the RHS on the right hand side? It will be equal to C0 into C1 plus C1 C2 plus C2 C3 plus dot plus Cn into plus C1 into Cn plus Cn into Cn. Okay, tell me, Alpha, are you getting? Okay, next. Okay, let us do another one. Question number 2. Show that C0 plus 2C1 plus 3C2 plus 4C3 plus dot plus n plus 1 whole to the whole Cn is equal to n plus 2 whole to the whole n plus 2 whole 2 to the power n minus 1. Question number 3. Show that, okay, if you have done number 2, you might be able to do number 3 as well. Show that C1 plus 2C2 plus 3C3 plus dot plus NCN n into Cn is equal to n into 2 to the power n minus 1. Question number 4. Question number 4. Show that C0 plus 3C1 plus 5C2 plus dot plus 2n plus 1 into Cn is equal to n plus 1 whole into 2 to the power n. Question number 5. Show that two C0 plus 2 square by 2 into C1 plus 2 cube by 3 into C2 plus 2 to the power 4 by 4 into C4 into C3 plus dot. Tell me, should I start everyone? Number 2
Sir,
Okay.
can you wait a minute?
plus 2 to the power n plus 1 divided by n plus 1 into Cn is equal to 3 to the power n plus 1 minus 1 upon n plus 1.
Sir, I have sent you number 2.
Okay, I'm checking. Keep on solving, everyone. Yes, Ritam, your answer is absolutely correct. Okay, everyone said, keep solving. Yes, Adrija, your method is correct. I mean, your proof is also correct. Yes, Kote, your answer is correct. Rhythm, your answer is correct. Okay, let us start. So there are two methods of proving number two. Okay, there are two methods of proving. Method one. Okay. See, since the coefficients are in AP, whenever you see this pattern, the coefficients are in AP 1, 2, 3, 4, 5, 6, like this. Okay, what you do is, okay, at first you write down the sum in the increasing order, and then you write down the sum in decreasing order. Okay, at first you write down the sum in increasing order, then again you write down S in decreasing order. That is n plus 1 into Cn plus n into C1 plus dot 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 plus C0. So when you add, S plus S will become 2S. 2S is equal to n plus 2, n plus 2 into C. Achha, over here C0 and C1 are Cn are same. So n plus 2 into Cn, or you can say C0, plus n plus 2 into C1 plus n plus 2 into C2 plus dot 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 plus n plus
Sir, I
2
said.
into C0. Okay. Yes, wait, I'm checking. When you take n plus 2 common, within brackets you are going to get C0 plus C1 plus C2 plus dot 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 plus Cn. Oh, wait a minute. Last one will be Cn. So tell me, what is C0 plus C1 plus C2 plus up to Cn? Tell me, what is the value? What is the value of C0 plus C1 plus C2 plus up to Cn? Tell me. 2 to the power n? Right. So 2s will be equal to n plus 2 into 2 to the power n. This implies s is equal to n plus 2 into 2 to the power n divided by 2, which is equal to n plus 2 into 2 to the power n minus 1. Okay. Tell me. Is it clear to everyone? Tell me. Somebody, Samratni, Madhuryo, Anvesha, are you people getting? Yes or no?
Sir, can you show the questions
Yes,
once
sir.
again?
Question? What rhythm? Rhythm? What?
Question number 5, last question. Can you show it once again? Yes.
Yes. Jatra, did you understand? Number two.
Yes, sir. Yes, sir.
Okay. Pallavi, is it clear?
Yes.
Ronak, Shashwato, Shreyasi, are you getting? Swankit,
Yes, sir.
Abhigyan, are you people getting?
Yes, sir.
Okay. So if
Sir,
you people have,
once again.
Acha, okay. This is method one. Rasheshwari, did you understand?
Yes, sir.
This is method one. Method two. I'll show you another method. Pay attention, everyone. I'll show you another method. Pay attention. Oipsha, did you understand this one?
Yes, sir.
Okay, method two. Okay, wait. Method two. So pay attention, everyone. Okay. This is also another method, a good method. So what do you have? You have C0 plus 2C1 plus dot 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 plus n plus 1 into Cn. Okay. So basically it is nothing but summation of r plus 1 into Cr from r equal to 0 to n. Okay. R plus 1 into Cr. Okay. Summation of r equal to 0 to n. R plus 1 into Cr. Okay. So whenever you see that there is some coefficient, some linear coefficient in front of Cr, then you can use this method. So everyone, you people tell me what is 1 plus x whole to the power n? it is equal to C0 plus C1x plus C2x square plus C2x cube plus dot plus Cnx to the power n.
You can
Okay.
multiply x.
Yes. Now you people tell me, in front of, if I need some constant in front of x, I can differentiate both sides, right? But if I differentiate currently on both sides, I'll get one C1. Are you people getting? Currently, if I differentiate both sides, I'll get one C1. Currently, if I differentiate both sides, I'll get two C2. But I need three C2. So I'll multiply by x on both sides. Multiplying it by x on both sides, I'll get x into 1 plus x whole to the power n is equal to C0x plus C1x square plus C2x cube plus dot plus Cnx to the power n plus 1. Now you people differentiate. So now when you differentiate dy dx of x into 1 plus x whole to the power n, okay, you'll get C0 plus 2C1x plus 3C2x square plus dot plus n plus 1 into Cn x to the power n. Okay, you people know a little bit of differentiation, right? Had done it in basic maths. Tell me. Everyone knows. Those who are not there, you people also know, right? Shwankit,
Yes,
Arif,
sir.
you people know. Joitra, Arif, you know this,
Yes,
right?
sir.
Yes, sir.
Abhigyan, Advija, Abhiksha, you people know, right?
Yes,
Yes,
sir.
Yes.
sir.
Okay. So over here we are going to use UV rule. Okay. X into dy dx of 1 plus x whole to the power n plus 1 plus x whole to the power n into dx by dx. Okay, this will give us C0 into 2C1x plus 2C1x plus 3C2x square plus dot. Over here we are going to get nx into 1 plus x whole to the power n minus 1. Okay, plus when you differentiate dx by dx will become 1. So 1 plus x whole to the power n is equal to C0 plus 2C1x plus 3C2x square plus dot. Okay. So you people tell me over here now what we should substitute.
One.
Okay, so that x gets vanished. Yes. So putting x equal to 1 will get the result. Tell me, did you people understand this method also? We get n
Yes.
into,
So when to use it?
whenever there is a linear coefficient in front of all the binomial coefficients. Okay, understood? Shashwat. Plus
Okay, sir.
2 to the power n is equal to the required result C0 plus 2C1 plus 3C2 plus dot. Okay, and accordingly, you should understand what you should multiply over here so that you get those coefficients. Understood? Like Shashwato, at first I realized that when you differentiate over here, C0 will get vanished and I'll get only one C1, two C2, three C3, uh, and so on and so forth. Are you getting, Shashwato?
Yes, sir.
So that is why I multiplied by x so that I can increase the coefficient. Okay, when I differentiate. Okay, on the left hand side, what are we getting? When you take 2 to the power n minus 1 common, we are getting n plus 2. Hence proof. Okay. Has everyone understood this method also? Tell me. Tell me,
Sir, can
Madhujo,
you,
Ras. Yes, tell me.
can you check my print? Yes,
Wait,
sir.
I'm checking. I'm checking. Yes. You, everyone has done by differentiation only, those who have got it. Okay. Tell me, Ronak, did you understand? Method 2 also?
Yes, sir.
If if you people have understood, you should be able to solve number 4. Everyone quickly solve.
Sir,
Yes,
I have
Samrat.
checked.
Yes. Give me some time. I'm checking. Samragni, your answer is correct. Okay, everyone, give me some time. I'm checking one by one. Yes, Olive, your answer is correct. Adrija, number 3 is correct. So now you people need 2C2. Pratya, your answer is correct. Ritam, okay, Ritam, number 4 is correct. 3 is also correct. But number 2, okay, number 2, I'm trying to understand. Give me some time.
So number 2, you already said it
No,
was
no, no,
correct. I
no.
said to number 5.
Yes, yes, I'm talking about number 5. Sorry. Actually, number 5, I'm trying to understand. Let me think.
And number 5, there I have done a mistake. That is, entire thing, the answer I've written is supposed to be divided by n plus 1. I've written it later.
Okay, okay, that is fine, no problem. But actually, I'm trying to understand what have you done. Okay, NCR by if TR is equal to NCR by R plus 1 into 2 to the power R. After that, how did you get simplification directly? I'm trying to understand. Oh, when you
Sir, I have
simplify,
taken
you'll when you simplify, you'll get it, and then you oh, acha,
yes,
I understood. I understood. I understood. Yes, this is also correct. I have done it by different method. Yes, Ahir, your answer is correct. Number 3. No, no, you have sent number 2, right? Yes, number 2 is correct. Shashwato, number 3 is correct. Arif, 3 is correct. Everyone send your answers with proper numbering. Okay, Anvesh, Adrija, 4 is correct. Okay, I'm starting everyone. I'm starting with number 3. So everyone, now we need 1C1, 2C2, 3C3, 4C4, and Cn. Right. So basically we need summation of RCR. Right, everyone. Over here, do you think we should multiply anything? We should multiply any power of x? Tell me. Now over here we need summation of RCR. Okay. Yes, Anvesha, your answer is correct. Okay. So what you can do is you can directly solve, directly simplify. Yes, Samragni, right answer. You can do it by addition also, method 1 also. Okay. But also you can do it by differentiating directly over here. Are you people getting? Directly you can differentiate. C0 will be gone. Right. Differentiating both sides. Both sides. What do we get? N into 1 plus x whole to the power n minus 1 is equal to C1 plus C2 plus 2C2 x plus 3C3x square plus dot plus n into Cn into x to the power n minus 1. Now you substitute x equal to 1. Putting x equal to 1, we'll get the result. Okay. We'll get C1 plus 2C2 plus 3C3 plus plus n into Cn is equal to n into 2 to the power n minus 1. Okay. Is it clear to everyone? Tell me. Rasheshwari, Anvesha, you have done it. Rasheshwari, is it clear? Pallavi, have you understood?
Yes, yes.
Shreyasi, Suvankit, Shinika, Abhiksha, is it clear? Tell me.
Yes, sir.
Okay. If you people have understood, tell me number 4. Yes, Pratyay, number 4 is correct. Okay, I'm starting with number 4, everyone. Pay attention. So this one, I'm going to use by method 1. I'm going to solve it by method 1. C0 plus 3C1 plus 5C2. Pay attention. This is number 4. So everyone, let us say that this is the S. Okay. So writing it in reverse order. That is 2n plus 1. Cn plus. Okay, next one will be 2n minus 1. C1 plus dot 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 plus C0 is equal to S. Adding. In addition, what are we getting? 2n plus 1 into C0 plus 2n minus 1 plus 2n plus 1 into C1 plus dot 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 plus 2n plus 1 into Cn. This is equal to 2s. Okay. So I've got 2s is equal to 2n plus 1 into C0 plus C1 plus C2 plus C1 plus C2 plus dot 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 plus Cn. So what is C0 plus C1 plus C2 plus up to Cn? 2 to the power n. This will be equal to 2n plus 1 into 2 to the power n. This implies S is equal to 2n plus 1 into 2 to the power n by 2, which is equal to 2n plus 1 into 2 to the power n minus 1. Okay. But something else is here, I guess. Let me see. Okay. That means I'm making some mistake. Oh, so when you added, everyone, when you added, it is 2n plus 1 plus 1, 2n plus 2. Sorry, everyone. It should be 2n plus 2. 2n plus 2. Up to 2n plus 2. 2n plus 2. Okay. 2n plus 2. 2n plus 2. Okay. So when you take 2 common, you are going to get n plus 1 into 2 to the power n. Okay. Hence proved. Is it clear to everyone? Tell me. Miss Family, is it clear? Swankit?
Yes, sir.
Okay. Pallavi, Chaitra?
Yes, sir.
Okay. Abhigyan, is it clear? Madhurjo, is it clear?
Yes.
Rasheshwari,
Yes, sir, it's clear.
have you understood?
Yes, sir.
Okay, next. Now, over here you see number 4. Number 4, we need something in the denominator. You see 2 square by 2. Okay. So this one we have to prove 3 to the power n plus 1 minus 1 upon n plus 1. So everyone pay attention. What we can use over here. So pay attention. This is number 5. So whenever you see that we need something in the denominator, okay, always think about, okay, simplifying. I mean, writing it in the short form first. Okay, pay attention. So we have got 1 plus x. So basically this is x square by 2. Can you people understand? Can you people understand this? X square by 2, x cube by 3, x to the power 4 by 4, x to the power 5 by 5. Are you people able to feel integration over here? Tell me, x to the power n plus 1 upon n plus 1. Tell me. By looking at the pattern, are you people able to feel that we have to use integration over here? Tell me.
Yes, sir.
X bar n plus 1 upon n plus 1. X bar 4 by 4. X cube by 3. Okay. So see, and instead of x, we have to substitute 2. Okay, so everyone, let us just integrate 1 plus x whole to the power n. So what is 1 plus x whole to the power n?
Sir,
1
could
plus
you
x
say the
whole.
question once?
Yes. This is the question.
Okay, sir.
Okay. So what is 1 plus x whole to the power n? Again, c0 plus c1x plus c2x square plus up to cnx to the power n. Okay. So let us integrate both sides. On integrating, what do we get? 1 plus x whole to the power n. Okay. Currently, I'm not simplifying the left hand side. Okay. This will be equal to c0x plus c1 into x square by 2 plus c2 into x cube by 3. See, we are getting the pattern plus cn into x to the power n plus 1 upon n plus 1. See, are you people able to understand? We are getting the pattern. Okay. So now what you have to do is, okay, left hand side also will simplify. Now what you have to do is, instead of x, we should have got, okay, instead of x, we have to substitute 2. So what you do is, you just put the limits from 0 to 2. Okay, everyone, you just put the limits from 0 to 2. Understood? So that when you open the brackets, okay, instead of x, you have to substitute 2 once and then 0 again. Are you people able to understand? Yes or no? This implies 1 plus x whole to the power n plus 1 upon n plus 1. Okay, from 0 to 2 is equal to c0 x plus c1 x square by 2 plus dot 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 plus cn x to the power n plus 1 upon n plus 1 from 0 to 2. Okay. So what are we getting? Left hand side will get the result c0 into 2, that is 2c0 plus 2 square by 2 into c1 plus 2 cube by 3 into c2 plus dot 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 plus 2 to the power n plus 1 by n plus 1 into cn. And on the left hand side, what are we getting? When you substitute 2, we are getting 3 to the power n plus 1. Okay, when you substitute 0, we are getting 1. So minus 1 upon n plus 1. Hence proved. Tell me, is it clear to everyone? Or should I explain how to interpret when to use integration and when to use differentiation in binomial series? Tell me. Are you people getting? Hello. Tell me, Adrija, is it clear? Adrija, Isha,
Yes.
Abhigyan. Adrito, is it clear?
Yes, sir.
Pallavi, Dasheshwari, Anvesha, did you people understand?
Yes, sir.
Okay. Madhurjo, is it clear?
Yes.
Okay. Next. But there is another method. If you don't want to use integration, method 2, I have another method. What you do is you write down the rth term. So what is the rth term? TR is equal to 2 to the power r plus 1 into CR upon r plus 1. Right, tell me everyone. That is NCR upon r plus 1. So what you do is you simplify this a little bit. Okay. I mean, what is S? S is equal to summation of r equal to 0. Summation of r equal to 0 to n 2 to the power r plus 1 into NCR upon r plus 1. Okay. NCR upon r plus 1. Okay, let us simplify. So I'm going to simplify NCR upon r plus 1 first. Okay. And if there is any constant, I will take it outside. Okay. So what is NCR upon r plus 1? Let's see. So NCR is equal to NCR upon R plus 1 is equal to n factorial divided by R factorial into n minus R whole factorial multiplied by 1 by R plus 1. Okay. Now see this R plus 1, if I multiply by R factorial, what do we get? Tell me everyone. R plus 1, if I multiply by R factorial, what do we get?
R plus 1 factorial.
R plus 1 whole factorial. So this
Yes.
becomes n factorial divided by R plus 1 whole factorial into n minus R whole factorial. Okay. So everyone, this n factorial, I mean, if it was n plus 1 whole factorial, I could have directly written n plus 1 into CR plus 1, n plus 1 CR plus 1. So tell me, what should we multiply in the numerator so that we'll get n plus 1 whole factorial? Tell me.
So you need to multiply divide by n plus 1.
Exactly. So multiplying and dividing by n plus 1. So we are getting 1 by n plus 1 into n plus 1 whole factorial divided by r plus 1 whole factorial into n minus r whole factorial. Tell me, is it clear to everyone? Yes or no? So basically this becomes n plus 1 CR plus 1 upon n plus 1. Okay, this is what we are going to get. N plus 1 CR plus 1 upon n plus 1. So now the whole summation. So now the whole summation S will be equal to summation of R equal to 0 to n 2 to the power R plus 1 upon n plus 1 into n plus 1 CR plus 1. Okay. So taking 1 by n plus 1 outside. Okay. Taking 1 by n plus 1 outside. And what are we getting in the brackets? In the brackets, let us simplify. So in the brackets, we are going to get 1. For R equal to 0, we are getting 1. Wait a minute. For R equal to 0. Okay. No, for R equal to 0, we will get n plus 1 2 to the power R. N plus 1 into 2 to the power R plus n plus 1 C2 plus n plus 1 C2 into 2 to the power. For R equal to 0, it will be 2 to the power 1, sorry. Plus 2 square plus n plus 1 C3 into 2 cube plus dot 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 plus n plus 1 CR plus Cn plus 1, that is n plus 1 Cn plus 1 into 2 to the power n plus 1. Okay. Are you people able to identify that it is written in the form of NC1 into 2 plus NC2 into 2 square plus NC3 into 3 square 3 cube plus NC4 into 4, sorry, why it's 3 cube, it is 2 cube, NC4 into 2 to the power 4 plus dot 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 plus NCN into 2 to the power n. Tell me, are you people able to identify? Are you people able to compare? Does this look familiar to you people? NC1 into 2 plus NC2 into 2 square. Instead of 2, you people imagine x. NC1 into x plus NC2 into x square plus NC3 into x cube. Are you people able to imagine? People able to analyze? Tell me. This looks familiar, right? Familiar to some expansion. Yes or no? Tell me. Can anyone tell me? Raise your hand.
Yes, sir.
Raise your hand, tell me. Does it look familiar? Okay, only Ritam. What about others? You people are able to identify? Yes, Ritam, tell me.
So it is the expansion of 1 plus x to the power n plus 1 except that nc0 n plus 1 c0 term is missing.
Exactly. Only the C0 term is missing. So that I'll add it by myself. Right. So let us add it. Adding n plus 1 C0 and subtracting n plus 1 C0. Okay. See if you people are unable to understand. Okay. Or is it going above your head? Let me know. I'll explain. If you ask me 100 times, I'll explain you 100 times. Tell me. This will become 1 by n plus 1 into within brackets. You are going to get 1 plus 2 whole to the power n minus 1. So see, we are getting the result 3 to the power n minus 1 upon n plus 1. Hence proved. Tell me, is it clear to everyone? Yes or no? Okay. If you are unable to understand, let me know. Yes, Shubhankit, is it clear? Tell me.
Yes, sir, clear.
Shreyasi, Samradni, Ronak, Pallavi, Pratyay, Jaitra, is it clear? Farooq,
Yes, sir. Sir,
yes,
can
good.
you please show question number 4 with the differentiation?
4 with differential. This one, C0
Yeah,
plus 3C1 plus 5C2.
yes,
Okay, let
sir.
me try. I haven't done it yet
I'm unable to do it using it.
using differentiation.
Yeah.
So let me try. Let me try. Anyone has done it using differentiation? Number 4. Okay. So this is number 4. Okay. So over here, what is S is? S is summation of R equal to 0 to N 2R plus 1 into 2R plus 1 into Cn. Okay. In order to do this, I need the difference of powers also. Are you getting over here? We need the difference of powers also. Acha, what is 1 plus x whole to the power n? 1 plus x whole to the power n is equal to C0 plus C1x plus C2x square plus dot 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 plus Cnx to the power n. But Jaitra, this is not enough, right? We need the
Yeah.
difference of powers also. Yes or no?
Yes, sir. Yes, sir.
Okay. So what I'm going to do is I'm going to remove the odd power terms. Okay, odd. Let me see. But C1 should be there. Okay. No, no. This can create a problem. Only the powers has to be odd. Plus C2 plus C1.
I had multiplied it with x square, but
No, no,
at the end it's giving some another result.
no, no. It will not come multiplying by. No, try to understand. Okay, there should be a difference of 2 in the power. Then only you'll get by differentiation directly. Mm,
Sir, we can do it by differentiation, but that will be a long step. Like I can write it 1 plus x to the power n plus 1. Meaning
one,
the
1
given
minus x whole
sequence.
to the power n.
No, the given sequence plus 1 plus x to the power n. Then the x is then the terms come
No,
like in.
no, let me think. Let me think. I'll tell you. Okay, Jyotra, give me some time. I'm thinking and telling you. Okay.
Okay, sir.
Okay, give me some time. Till then, let us move on. Okay. Question number 6. Show that show that C0 plus C1 upon C0 into C1 plus C2 upon C1 into C2 plus C3 upon C2 dot 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 Cn minus 1 plus Cn upon Cn minus 1 is equal to is equal to n plus 1 whole to the power n upon n factorial. Solve, everyone. I have to prove this is equal to n factorial. Question number 7. Find the coefficient of x to the power 50 in 1 plus x whole to the power 101 into 1 minus x plus x square whole to the power 100. Solve. Question number 8. If 1 plus x plus x squared whole to the power n is equal to a0 plus a1x plus a2x square plus dot 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 plus an x to the power n for n belongs to natural numbers, so that for all x belongs to R, part 1 a0 plus a1 plus a2 plus dot 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 plus a2n is equal to 3 to the power n. Part 2 a0 minus a1 plus a2 minus a3 dot 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 plus a2n is equal to 1. Okay, part 3. Part 3. A1 plus A3 plus A5 plus dot 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 plus A2n minus 1 is equal to 3 to the power n minus 1 by 2. Okay, keep solving. Let me see 8 who has done it. And number 6. Yes, Adija, your answer is correct. Ritam, your answer is correct. Mahir, your answer is correct. Joytra, your answer is correct. Totally solved, everyone? Yes, Rashtrashwari 7 is correct. Adrija 7 is correct. Okay, let us start number 6, everyone. Ritam 7 is correct. Pratyay 6 is correct. Madhujo 7 is correct. Ronak 7 is correct. Okay, I'm starting with number 6. So first of all, let us write down the general term. Yes, Aditya 7 is correct. Let us first of all, everyone write down the general term. Okay, let us see how the term looks like. Okay. So generally we can write it as, generally we can write product of, do you people remember, right? Product can be written like this. Product of r equal to 0 to n minus 1. CR plus 1 upon r. Upon CR, I guess. Let me see. CR plus 1 upon CR. Okay. You people remember, right? What is NCR plus NCR plus 1? Anyone remembers? What is NCR plus NCR plus 1? Tell me. What is NCR
N
plus
plus
NCR?
1 CR plus 1.
N plus 1 CR plus 1. Very good. This will be equal to continued product of R equal to 0 to N minus 1. N plus 1 CR plus 1 upon NCR. Right? Or are you getting? This
Yes,
will
sir.
be equal to continued product of R equal to 0 to N minus 1. N plus 1 CR plus 1 will be equal to N plus 1 whole factorial divided by R plus 1 whole factorial multiplied by N minus R whole factorial multiplied by R factorial into N minus R whole factorial divided by N factorial. So let us do some cancellation. These two gets cancelled. Okay. R factorial and this will go by R plus 1. This will go by N plus 1. So finally, what are we getting? Continued product of R equal to 0 to N minus 1, N plus 1 upon R plus 1. Okay. So everyone, let us start substituting. R equal to 0 to, you can substitute, keep on substituting. So we get N plus 1 upon 1 into N plus 2 upon 2 into, sorry, N plus 1 upon 2 into N plus 1 upon 3 into N plus 1 upon 4. Keeps on going up until N plus 1 upon N. This will be equal to N plus 1 whole to the power N upon N factorial. Tell me. Hence proof. I hope this is clear to everyone. Tell me, Abhiksha, is it clear? Abhiksha, Abhigyan, is it clear?
Yes, sir.
Yes, sir.
Yes,
Sir, did you
Abhiksha.
see my question?
Yes, Abhigyan number 7 is correct. 7 is very easy, everyone. You should be able to solve. Yes, Shinika, number 6 was correct. Ritam. Yes, Ritam, number 7 is correct. Number 8, part 1 is correct. Part 2 is correct. Okay, let me start with number 7. Number 7 is very easy. Samragni, is it done? Number 7, quickly send. Okay, let us start. Number 7. We need to find out the coefficient of x to the power 50 in this expression. Let us see. So over here, I'll make use of the formula. Over here, I'll make use of that formula. 1 plus x into 1 minus x into 1 minus x plus x square. Okay, I'll make use of that formula. So what is 1 plus x? Whole to the power 100 into 1 minus x plus x square whole to the power 100. Achha, this is 101, so it should be multiplied by 1 plus x. This will give us 1 plus x cubed whole to the power 100 multiplied by 1 plus x. Let us simplify. This will give us 1 into 1 plus x cubed whole to the power 100 multiplied by plus x into 1 plus x cubed whole to the power 100. Yes, Ahir, your answer is correct. Ritam, part 3 is correct. Atrija, part 1, 2 and 3 are correct. So let us start. Now over here we need the coefficient of x to the power 50. Do you think you people will get any coefficient of x to the power 50 over here? Tell me. Do you think you will get coefficient of x to the power 50 over here? Tell me. Hello, are you people getting? Tell me. Shashi, what do you think? Will you get x to the power 50 over here? What do you think? Shashi, Jatra, tell me. Hello, am I audible to everyone?
Yes, sir.
Okay. So tell me, Jatra, will we get any x to the power 50 over here? What do you think?
No, sir.
Yeah,
Yes, sir. Yes, sir. Yes, sir.
we'll get. What is the coefficient of x to the power 50 over here? Tell me.
No, sir. We won't get.
We won't get any x to the power 50 over here. And similarly, we won't get any x to the power 50 over here as well. Right? Because all the powers will be of the form 3r plus 1. Right? Over here, all the powers will be of the form 3r, which is not equal to 50. And over here, all the powers will be of the form 3r plus 1. And tell me, whenever you divide 50 by 3, what is the remainder? If you divide 50 by 3, what is the remainder? 2. So that is why over here coefficient of x to the power 50 is 0. Okay. Next. So we start 8 part 1, 2 and 3. Oh, these are so very easy. Tell me, how will we get the sum of all the coefficients? Quickly. It's not even a problem. This kind of problems we have done it in class 9, 10. Tell me, how will we get sum of all the coefficients? Tell me, a0 plus a1 plus a2 plus up
Sir,
to an.
is equal to 1.
Exactly. What happened, everyone? Put x equal to 1. What do we get? a0 plus a1 plus a2 plus dot plus up to an will be equal to 1 plus 1 whole to the power n, which is equal to 3 to the power n. Right, tell me. Shreyashi, are you getting? Yes or no? Hello, Shreyashi, can you
Yes,
hear me? Joytra, Abhiksha, Avigyan, are you people getting? Tell me.
Yes, sir.
So, Abhiksha, now you tell me, in order to get a0 minus a1 plus a2 minus a3 plus up to a2n, what shall we substitute? No? I need alternately positive, negative, positive, negative, positive, negative. What shall we substitute for part 2? Apiksha?
Sir, x equals to 2.
X equal to -1, right? So that this becomes negative.
Sir, can you show the question once more?
You didn't even copy, you didn't even.
Oh, yes, sir.
Apiksha, you are not doing anything else, right?
No, sir. Sir, I was understanding the previous one.
So previous one you have understood properly, or should I explain? Tell me.
Sir, can you explain the part from second part? My second line.
Yes. You see, over here, will you get any x to the power 50 over here? Tell me. Will you get any x to the power 50 over here? Tell me, Apiksha.
No, sir.
No. Why? Because all are cubes. You are going to get x cube, x to the power 6, x to the power 9, x to the power 12, x to the power 15, and so on. All the multiples of 3. Right? 50 is not a multiple of 3, right?
Yes, sir.
Over here, you are going to get x to the power 3 plus 1, right? Because x is multiplied.
Yes, sir.
So you're going to get x to the power 4, x to the power 7, x to the power 11, x to the power 10, x to the power 13,
So the
x to the power
coefficient
16.
of x to the power 50 will be 0.
Exactly. You're not going to get x to the power 50 only.
Okay,
Is
okay,
it
sir.
clear?
Yes, sir.
Yes. Shamini, is it clear? Number 7. Hello, Shamini, is it clear? What happened? Everyone respond. Shamini, are you getting? Oh, she's not there. So this will give us A0 minus A1 plus A2 minus A3 dot 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 up to this was A n x to the power n, no? So -1 whole to the power n, x to the power n. Okay, dot 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 dot. This will give us the result. Tell me, anyone having any doubt, you can ask me. Okay, next. So Shinika, can you tell me how to get the third one? I know the first one. I know the second one. How to get the third one? Can you tell me? I need to eliminate A0, A2, A4, and all those things. How to do it?
So we can subtract the second equation from the first equation.
Exactly. Exactly. We have got A0
Also,
plus A1. Yes, tell me, Shumankit.
sir, in these questions, we are finding a0 plus a1 plus a2 till an. But in the question, we are given a0 plus a1 plus a2 till a of 2n.
I gave A2N. Let me see. Let me see. Let me see. Oh, it has to be 2N only. Actually, in the question, I wrote something wrong. It should be 8 2N x to the power n. Yes. X to the power 2N. Okay, now it is fine. Okay, by mistake, I wrote AN x to the power. Okay. So it is A0 minus A1 plus A2 dot 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 plus this will be 2N. This will be 2N plus A2N is equal to 1. So when you subtract, you are going to get A1, 2 into A1 plus A3 plus A5 plus dot 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 plus A2N minus 1. This is equal to 3 to the power n minus 1. So this implies the result A1 plus A3 plus A5 plus up to A2n minus 1 is equal to 3 to the power n minus 1 by 2. Is it clear, Shavankit? Shashwatu, are you people getting? Pallavi, is it clear? Tell me.
Yes, sir.
Okay. So question number 8 actually has some more parts, okay? Question number 8 actually has more parts. Okay. Question number 8, part 4. Okay. A0 plus A2 plus A4 plus up to A10, A2n is equal to 3 to the power n plus 1 divided by 2. Part 5, AR equal to A2n minus R for all R belongs to natural numbers. Part 6, Part 6, A0 square plus A1 square, sorry, minus A1 square plus A2 square minus A3 square, dot, 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 dot. Lastly, plus A2n square is equal to an. Part 7, A0 A1 minus A1 A2 plus A2 A3 dot, 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 dot. This should be equal to 0. Part 8, A0 A2 minus A1 A3 plus A2 A4 dot, 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 dot. It should be equal to an plus 1. Start everyone, quickly start. Yes, Adrija, right answer. Keep on solving everyone. If you people have understood parts 1, 2 and 3, you can at least solve 4. Yes, Pallavi, part 4 is correct. Shashwata, part 4 is correct. Andesha, part 4 is correct. Arif, part 4 is correct. Joyatra, part 4 is correct. Okay, starting with part 4, everyone. Now what do we need to do, everyone? I need A0 plus A2 plus A4, right? All A1, A3, A5 should be cancelled out. So what shall we do now? We need
Total
to
minus A1 plus A3.
add.
Add them.
Right, tell. Instead of subtracting, now we need to add. Okay, on addition, what are we getting? On addition, all the middle terms will get cancelled. We are getting 2 into A0 plus A2 plus A4 plus up to A2n is equal to 3 to the power n plus 1. So initially, are you getting? This implies A0 plus A2 plus A4 plus up to A2n is equal to 3 to the power n plus 1. The whole thing is divided by 2. Solve part 5, everyone. Think.
Sir, I have sent you. Can you check once?
Yes, yes. Rhythm, part 5 is correct. Okay, now the coefficients has to interchange. Think. What shall we do? Tell me, Ahir, did you understand 8 part 4? Abhigyan, Shinika, did you people understand?
Yes.
Yes, yes.
Okay. Kamali, did you understand? Oh, she's not there only. Samragni, did you understand?
So I didn't completely solve number 5. Can you check?
Yes, part 5, I understood. Like your approach is correct. Can you proceed? Okay, let's start. Over here, I need to interchange the coefficients. So what I'm going to do is I'll use one substitution. Okay, over here, I'll use one substitution. Okay, putting x is equal to 1 by x in the identity. So what have we got? In part 6, okay, part 5 actually. Okay, putting x equal to 1 by x in the identity. Okay, what are we getting? 1 plus 1 by x plus 1 by x square whole to the power n is equal to a0 plus a1 by x plus a2 by x square plus dot plus a2n by x to the power 2n. Okay, next. So what I'm going to do is, now I'm going to multiply by x to the power 2n on both sides. Okay, to make it polynomial. Okay, multiplying by x to the power 2n by x to the power 2n on both sides. What do we get? Okay, we are going to get x to the power x square plus x plus 1 whole to the power n is equal to a0 x to the power 2n plus a1 x to the power 2n minus 1 plus a2 x to the power 2n minus 2 plus plus a2n. Okay. So see, they both are same, right? Both the identities are same. Yes or no? Tell me, everyone. Both the identities. Sorry, Jyotra, are you people getting? Shashwato,
Yes, sir.
Ankit, are you
Yes, sir.
getting? Both the identities are same. Shinika, Abhigyan,
Yes, sir.
Rasheshwari, are you people getting?
Yes.
Okay. So comparing 1 and 2. Okay. Comparing 1 and 2. What do we get? And 2. We get coefficient of x to the power 2n is a0 over here and over here a2n. Wait a minute. In the original equation, it is a2n. Wait, what have I written? Over here, wait, I'll rectify. Over here, it should be a2n. Okay, so over here, a2n. Okay, original equation. Comparing 2 with original equation. Adrito, are you getting? Adrito, Ronak, are you getting?
Yes, sir.
What do we get? A0 equal to a2n, a1 equal to a2n minus 1. Okay, ar equal to a2n minus r. Hence proved. Okay. So everyone try. So has everyone understood this one? Tell me, Pallavi, is it clear? This one?
Yes.
Okay. Yes, Ritam, part 7, part 8 is correct. Okay. So everyone solve part 6. Now we have got a0 square minus a1 square plus a2 square minus a3 square dot plus a2n square is equal to an. Okay. Now over here we should get a negative sign. Okay, everyone, let us start. Part 6. Over here we should get a negative sign. So over here we need to substitute. Substitute x equal to minus x in the equation. What do we get? X square minus x plus 1 whole to the power n is equal to a0 x to the power 2n. Okay. Okay, in equation number 2, a0 x to the power 2n minus a1 x to the power 2n minus 1. Tell me, Abhiksha, are you getting? In equation 2,
Yes, sir.
in this equation, I am replacing x by minus x. X power 2n minus 1 plus a2 x to the power 2n minus 2 minus dot up to a2n. And what is 1 plus x square? 1 plus x square is equal to a0 plus a1x plus a2x square plus a3x cube plus dot plus a2n x to the power 2n. Okay, now I'm going to multiply, just like in the previous problems we used to do. Achha, when we multiply these two, x square minus x plus 1 and 1 plus x square, what is the product? Tell me. X square plus x plus 1 and x square minus x plus 1. What is the product?
X to the power 4 plus x square plus 1.
Right, everyone. Are you people getting x to the power 4 plus x square plus 1?
Yes, sir.
So on product, we are getting x power 4 plus x square plus 1 whole to the power n. This will be equal to. Okay, let us multiply. Okay, I'm taking the second page. Okay, multiplying. Okay, equations 3 and 4. Okay, x power 4 plus x square plus 1. Okay, this will be equal to a0 x to the power 2n. Okay, so let us take the positive one first. Okay, a0 into this whole thing. A0 into this whole thing. Okay. Next. Plus a1x into this whole thing. plus a2x square into this whole thing. Okay, plus dot 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 plus an x to the power n into this whole thing. Okay, now I'll just compare the coefficients. Okay, everyone. I'll just compare the coefficients. Okay, so everyone, how are we getting a0 square? Over here, a0 square is the coefficient of x to the power 2n. Over here, a1 square is the coefficient of x to the power 2n minus 1. Right, minus a1 square. Are you people getting? Oh, sorry. X into x to the power 2n minus 1 is x to the power 2n only. Right, are you people able to see the pattern? A0 square is the coefficient of x to the power 2n. A1 square is the coefficient of x to the power 2n. A2 square is the coefficient of x to the power 2n only. So that means we need to compare the coefficient of x to the power 2n. Are you people getting? What is the coefficient of x to the power 2n in LHS? Can anyone tell me? What is the coefficient of x to the power 2n in LHS?
An.
In an. Okay. And what is the coefficient of x to the power 2n in RHS? It is the same thing, a0 square minus a1 square plus a2 square dot up to an square plus a2n square. Okay, hence proved. If there is anyone having any doubt, you can ask me. So once you people have done part 6, you can easily do part 7 also using the same equation. Over here also we have to do some comparison. Let's see. Okay, I need is in part 7. In part 7 we need a0 a1, a1 a2, a2 a3 dot. Okay. Okay. So a0 a1 is the coefficient of x to the power 2n minus 1. A1 a2 is also the coefficient of x to the power 2n minus 1. Are you people able to see? A2 a3 coefficient of x to the power 2n minus 1 and so on. Right, tell me everyone. A0 a1. Okay, let us say that this is equation 5. In equation 5, in the product, coefficient of x to the power, a0 a1 comma a1 a2 comma a2 a3 are all coefficients of x to the power 2n minus 1. Achha, now you people tell me, what is the coefficient of x to the power 2n minus 1 on the left hand side? Can anyone tell me? What is the coefficient of x to the power 2n minus 1 on the left hand side? Tell me, anyone? 2n minus 1 is odd, right? So can you get an odd power on the left hand side? Tell me.
No, sir.
It's not possible. Okay. But coefficient of x to the power 2n minus 1 in 1 plus x square plus x to the power 4 whole to the power n is 0. Hence, a0, a1 minus a1 a2 plus a2 a3 dot. This should be equal to 0. Hence proved. If you people have done this one also, can somebody raise your hand? Tell me. Oipsa, did you understand number 7? Tell me. Oipsa, Abhigyan. Do people understand? Shreyasi, did you understand? Tell
Yes,
me.
sir.
Yes, sir.
Pratyay, is it clear? Pratyay, Jayatra, Arif,
Yes, sir. Yes,
Rasheshwari, Anvesha, Ronak, Samragni, Shashwato, is it clear?
Yes, sir.
Right.
Yes, sir.
In the question, the sign will be interchanged.
Even if the sign interchanges or whatever it is, I mean, it doesn't matter, right? Tell me, Arif.
Oh, yeah,
Ultimately, we
yes,
can
sir.
take
Yes.
minus common. It doesn't matter. Again, if you people have understood part 6 and 7, can you people just tell me whose coefficients we need to compare to prove part 8? Raise your hand. To prove part 8, what do we need to compare? Raise your hand. In this equation only, what do we need to compare to get A0, A2? I mean, whose coefficients? What should be the power of x? Whose coefficients we should compare? Yes, for this one, Arif, tell me.
The x to the power 2n minus 2.
X to the power 2n minus 2, correct? Are you people getting? Tell me. If you are unable to understand or having any doubt, you can ask me now. I see A0, A2, A1, A3, A2, A4 is the coefficient of x to the power n minus 2, 2n minus 2. So write it down. Part 8. Tell me, Ahir, are you getting? Ahir, Adrito, Shavankit, Anvesha, Rasheshwari, Pallavi, are you getting? Tell
Yes,
me.
sir.
Yes, sir.
Hello, Pallavi, are you getting?
Yes, sir.
A1, A3, A2, A4, dot, 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 are all coefficients of x to the power 2n minus 2 in, okay, x to the power 2n minus 2. Hence, and now what is the coefficient of x to the power 2n minus 2 in LHS? Tell me. What is the coefficient? Somebody tell me. If I ask you, if I want to find out the coefficient of x to the power 2n minus 2, what is
N
there?
plus 1 or n minus 1.
And n
A
plus 1
n
or
plus
n
1. A
or
n
an
plus 1. Uh,
exactly. Basically, we should write an minus 1. 2n minus 2 it is. So it is equal to an minus 1, which can also be written as an plus 1. Hence proved. If there is anyone having any doubt, tell me. Akshay, is it clear? Or should I explain? Tell me. Aviksha, Shreyasi, is it clear? Tell me.
Yes, sir.
Rasheshwari, Anvesha, Adrito, is it clear? Tell me.
Yes, sir.
Yes,
Okay.
sir.
So next. Anyone has school tomorrow? Tell me.
but I have exams tomorrow.
Oh, you have exam tomorrow.
Yes.
So then two more problem. Okay. Question number 9. Prove that summation of k equal to 0 to n nck sin kx into cos of n minus k whole x is equal to 2 to the power n minus 1 into sin nx. Okay. Question number 10. Find the integral part. Find the. Just a moment. Forget about this. Question number 10. Find the sum of last 10 coefficients of, find the sum of last 10 coefficients of 1 plus x whole to the power 19. Solve. Okay. So I think very soon I'll be completing binomial also. Okay. So everyone, your PNC binomial test is also going to happen very soon. Quickly solve everyone, these two. Yes, Adija, your answer is correct. Rasheshwari, your answer is correct. Number 10. Joyatra, right answer. Ritam, check your answer again.
In question 10, it's 19 or 14 to the power.
19, 19.
I think so 14.
Oh, it's 19. Okay. Ahir, your answer is correct. Okay, we can start with number 19. Let us start. I need to prove that summation of NCK into KX. So let us start substituting. What is the sum? Let us start substituting. So basically, S is equal to C0 sine KX. Yes, option number 10 is correct. Into cos NX. NX, wait, let me see. For k equal to 0, it should be nx now. Sin kx into cos nx plus c1. Wait a minute. Oh, for k equal to 0, no? So sin x into cos nx. C0 is equal to sin x into cos nx. Yes, Adrija, number 10 is correct. Ronak, 10 is correct. Plus C1. Wait a minute. For k equal to 0, it is sin 0 into cos nx. Sin 0 into cos nx plus C1 sin x into cos n minus 1 whole x plus C2 sin 2x into cos n minus 2 whole x plus dot 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 dot. Again, you write down the sum in the reverse order. Cn into sin nx cos 0 plus C1 sin n minus 1 whole x cos x plus C2 sin n minus 2 whole x cos 2x plus dot 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 dot. Now you add. Yes, Pallavi number 10 is correct. Ahir 10 is correct. Wait a minute. Oh no, Ahir, can you simplify this? It is actually 2 to the power 19. I mean 1 plus x whole to the power 19.
Yes, sir.
Okay. Shirika 10 is correct. Adrito 10 is correct. So 10 is very easy. S plus S will give us 2s. 2s is equal to C0. Now, everyone, you tell me, what is sine 0 cos nx, sin nx cos 0? When you add, what is this? Sin A
Sin
cos
nx.
B plus cos A sin B, sin nx. Again, you people tell me, what is sin x cos n minus 1 whole x, sin n minus 1 whole x cos x? Tell me, sin A cos B plus cos A sin B. Right. So again, over here also sin nx. Again, next one will also be sin nx. Plus dot 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 dot. Sin nx. So we are getting the result. 2s is equal to sin nx common, sum of all the binomial coefficients. So s is equal to sin nx into 2 to the power n divided by 2. Tell me, Shreyasi, is it clear?
Yes, sir.
Okay. Shinika, have you understood? Adiksha,
Yes.
Abhigyan, is it clear?
Yes, sir.
Adrito, have you
Yes.
understood? Rasheshwari, Anvesha, is it clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Shivankit, is it clear?
Yes, sir, clear.
Pratyay, have you understood? Yes. Number 10, Pratyay, it is correct? Okay. Solve the last one. Those who have done it, fine. Solve the last one. Actually, Oriva got a simplified answer. Yes, Joyatra, your answer is correct. Okay, let us start. What do I need? I need the sum of all the last 10 coefficients. Okay, last 10 coefficients. So the last 10 coefficients will be, this is number 10. What is the sum of the last 10 coefficients? Okay, what is the total number of terms? Tell me. What is the total number of terms in 1 plus x whole to the power 19? How many terms are there?
So 20.
20. So basically, the sum of the first 10 coefficient is equal to the sum of the last 10 coefficients. Yes or no? Right. What is the required sum? The required sum will be equal to from 11th term, that is 19C10 plus 19C11 plus 19C12 plus dot 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 plus 19C19. Okay, next. So everyone, 19C10 is also equal to 19C9. Okay, let us say that this is S. Another way to write S is 19C9 plus 19C8 plus 19C7 plus dot 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 plus 19C0. When you add them up, when you add, 2S will be equal to 2S will be equal to 19C0 plus 19C1 plus 19C2 plus dot 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 plus 19C19. So what is 19C0 plus 19C1 plus 19C2 up to 19C19? What is the sum? Tell me. 2 to the power 19. So the value of S is equal to 2 to the power 19 by 2, which is 2 to the power 18. Is it clear to everyone? Tell me. Abhigyan, is it clear?
Yes, yes.
Arif, have you understood? Okay. Okay, Samragni, have you understood? Tell me.
Yes, sir.
And Shavankit, is it clear?
Yes, sir, clear.
Okay. Okay, so I think everyone, we can keep it till now. Next class will again continue. Okay. Aisha, you can wait. Okay, rest. You people can wait or as per your choice. Okay, I'll be solving question number 5. Okay, hello, Aisha, can you hear me?
Yes, sir. I will wait.
Yes, you can wait. Others, okay, I mean, you can wait or you can leave, no problem. Okay. So what was question number 5?
Sir, on Sunday, will you discuss generating functions?
On Sunday?
On Friday.
On Friday, we'll discuss generating functions, definitely, as per discussion.
Yes, sir.
And
Thank you.
on Sunday, we have a test also, right? You people remember the second slot, ellipse hyperbola. Okay. So, Aisha, this was the question. I did some part. No, not this part. You're talking about which question? Tell me, Aisha.
Sir, question number 5 of the homework.
Question number 5. Get this question only. 1 plus x square whole square into 1 plus x whole to the
Yes,
power n.
yes.
A1, A2 and A3 are in AP.
Yes, sir.
Haven't I discussed it? I've discussed it over here. See?
Sir, I didn't understand.
Oh, I didn't understand. That's why.
Yes.
Okay. So see, 1 plus x square whole square is A0 x to the power 0 plus A1x plus A2x square plus A3x cube plus dot 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 dot. Right. The whole thing will simplify to this. Yes or no?
Yes, sir.
At 1 plus. Next. So what is coefficient of x? I mean, coefficient of x, x square and x cube are in AP. Right, tell me. Because A1, A2 and A3 are in AP. Tell me.
Yes, yes, sir.
First of all, let us simplify 1 plus x square whole square into 1 plus x whole to the power n. This will be equal to 1 plus 2x square plus x to the power 4 into 1 plus x whole to the power n. Is it clear? Sure.
Yes, sir.
When you simplify, when you open the brackets, you are going to get 1 plus x whole to the power n plus 2x square into 1 plus x whole to the power n plus x to the power 4 into 1 plus x whole to the power n. Right?
Yes, sir.
Next, what is a1? A1 is the coefficient of x. Will you get any x over here?
No.
Will you get any x over here?
No, sir.
We'll get it over here. Right,
Yes.
tell me. So what is the coefficient of x over here? What is the coefficient of x over here? Tell me.
Sir, N.
NC1, right? Expand to C0 plus C1x. Na? C1 means what? NC1.
NC1.
Understood?
Yes, sir.
Next, coefficient of x square. Over here will we get coefficient of x square? Tell me.
No.
No.
If we expand it, then we will get
So that's what I am asking, right? What's the coefficient of x square over here? Tell me.
NC2.
NC2. And over here it should be 2x
2,
square
2.
into 1, na? So 2. So understood how I got A2.
Yes, sir. So now I understood this part.
Okay. So similarly, A3, you can understand how I got NC3 plus 2 into NC1.
Yes, sir. Yes, sir. Now I understood.
Okay. Anything else, Oiksha?
No, sir.
Anyone else having any doubt? Tell me, Abhigyan, Advija, those who are present, Anvesha, Rasheshwari,
No, sir.
Samragni or Shreyasi? Okay.
No, sir.
Okay. So everyone, I think we can keep it till now. Next class will again continue. Thank you, everyone, and good
Thank you,
night.
sir.
Next class is the test.
Thank
Okay.
you.